This is difficult problem number 2. This one is difficult, and it makes sense why I couldn't get it in class. So we're supposed to find the area of this center section that's overlapped. Hold on one second. Something going off in the kitchen. Okay, now to find the center section, it's really a little challenging, but I'm going to show you how to do it real quick. This should be a quick video. First of all, the only thing they give us is the centers. Here's the center of this circle. They're not perfect. I did make some with I traced something on my paper that were perfect circles to make it help me out with this. So this is 6. The distance from center to center is 6. You also know that the radius of all these circles both these circles are going to be 6. So from the center to the edge of that circle is 6. From the center of this to the intersection, that's that would be the radius, right? Anything from the center to the circle is going to be the radius. The same with this. From this center to the circle is a radius, it's going to be 6, and the center to this edge of the circle is also going to be a radius, and it's going to be 6. So we have two equilateral triangles. They're all going to be the same. And if they're all going to be the same, then they're all going to be 6. And if they're all going to be 6, then their angles are all going to be 60. So we got 60, 60, 60. Watch how tricky this problem gets. 60 and 60. All right, so now we know how to find the area of a sector. I can extend this line out a little bit. Probably won't match up perfectly, but if you did, you can see that we have a sector here inside of all of this. So we can figure out the area of the sector. Now, what the sector is not going to include, it's not going to include this area and this area. If we're going to go, we'll call this point A. So we're going to do the sector from point A. This is A. Let me just get rid of these check marks. So this is A. This central angle of A is going to be 120 degrees. So we're just going to get the sector. I'm going to mark this and I'm going to totally erase it so that it doesn't mess up our picture. So let's pick another color here. So let's go with some orange. Okay, so this sector right here, which I'm going to erase in a minute, see the sector? It's the sector that comes from point A. So it's going to be part of that center section. So let's get rid of all that mess. Okay, so we're going to get that area of that sector. So to find the area of a sector, it's going to be, here's my sector thing. That's pretty pathetic. So let's just do that and add a sector. It's going to be the area of the circle, which is pi r squared. R is 6 times the fraction of the circle. So the circle is 120 over 360, which ends up being 1/3, right? And that's going to be 36 right here, right? Having writing problems all of a sudden. 36, so the 3 is going to go into 36, and so the area of the sector, the area of this sector from point A, so we'll call that sector A, is going to equal 12 pi. All right, now here's the tricky part. Now we're going to find the area of sector B. So if I did that, I'm just going to shade it in and then I'm going to erase it again. Let's just use this purpley color. If I did this sector, if I called this point B, and I found the area of this sector, which would extend this way, and it would color in all this, that would be sector B, right? Now they're going to overlap. So let's just figure out, let's continue this. Let's find the area of sector B, and guess what? The area of sector B is going to be the same thing because it's the same radius. It's going to be 12 pi. So if I add those together, 24 pi. Well, that's too much because it's going to overlap where all this diamond shape is. So if we subtract out one diamond, we should have the area, because that's the part where they overlap, so there's 2 of them on top of each other. So if we subtract out one of these diamonds from the 24 pi, it should give us the area including these little mini parts, because we have in this sector right here we have mini parts he and he, and in this sector we have many parts she and she. So if we subtract out these double triangles, we will have these still in it, but this overlap won't be there anymore. So to find out the area of these triangles, I'm going to find my I'm going to find the area of the triangles, so I have to make right triangles. And if you know your geometry, this means this is going to be 3. So, and this is going to be 30 degrees, and this is going to be 6. And that makes sense because the one opposite the 30 degrees is half of the hypotenuse, and the one opposite the 60 degrees is 3 root 3. It's root 3 times whatever the one opposite the 30 is. So let's do the area of the triangle is 1/2 the base of the big, we're going to do in the whole big triangle, the base of the big triangle is 6 times the height of the big triangle is 3 root 3. So the area of the top triangle is going to be 9 root 3, and the bottom triangle down here is the same, so we're going to take it times 2, so we're going to have 18 root 3. So our final answer is the overlap, which will include the little pieces over here, and then we have to subtract off the diamond shape that is on there twice, which is 18 root 3. And that is the answer to this problem. Where are you going? Oh, work. Oh my goodness, you're never here to eat.
Nope. Are you going anywhere tonight?
Huh?
Are you going anywhere tonight?
SAT prep. So I guess I'm going to have to take the truck.
Dad not here yet?
Yeah.
I have your card, by the way.
Huh?
I have your card, by the way.
I know. Alright, so anyway now, you can take the car, I'll just take the truck. I think my purse is in the car though.
Okay. Probably doesn't.
Worst case is I'll switch it out.